Now we are going to do the very similar thing that we explained before our break. So this is with coin battery, this is with 9-volt battery, and this is with 1.5 volt AA battery. So if I click start simulation, you see this one is glowing very little, and this one is doing fine. But if you see some exclamation mark at the top, so it says that it is warning, the LED is going to burn. This one, it is completely burned. Okay, so if you keep the cursor on it, it will explain you what is the problem. Current through the LED is 915 milliamps, that's a unit of current, while absolute maximum is 20 milliamps. So a very similar statement you can find it here. Current through LED is 61.9, while recommended maximum is 20. The usable lifetime of the LED may be reduced, which means it is going to burn faster. And this one, it is not at all, it is glowing, but it's very little. So what it tells you, the 1.5 volt, it's not giving you enough light. And 3-volt battery, if you see here, it is written 3-volt battery, it is giving you current, sorry, it is giving you light, but that is also with some warning. And 9-volt battery, when you connect, it is completely burning. So we need some mitigation step to avoid this burning issue, because if you can control that, the light coming from the LED can also be controlled. Okay, it's like both of you know already, it is the resistor that we need to connect. I'm going to delete these components. Okay, now I'm going to take the resistor. Now the question is, should I connect it in the positive terminal or negative terminal? So the answer is,
Sir,
you can, yeah,
positive.
yeah,
Sir,
okay,
you can change the poles of the battery, sir. That we can connect the
yeah,
resistor easy.
okay. So what I'm saying, it is positive is generally we connect, but it can be connected in positive as well as in negative, no problem about it. You can connect in any leg. Okay,
Okay.
so I am connecting somewhere in the negative. You already tried it positive, so I am connecting negative. Okay, so okay, great. Okay, now if I click start simulation, now there is no problem, right? So you have the resistor,
So
and so
what with the resistor do?
I will explain that. So with the resistor and LED and battery, the connection is complete. You are not having any burning issues. Everything is good. Now, before explaining what is resistor, I will explain you what is LED. So LED, the light emitting diode, unlike bulb needs more voltage to lit up. Okay, suppose if you want to turn on a bulb, you need something like a 9-volt, 10-volt, more than that. Okay, but LED, it can start glowing as low as 2 volt. So in electronics, we are not going to deal with a very high voltage applications, generally I'm saying. So if you take our cell phone, it is generally operating at around 5 voltage. Our household voltage is 220. Okay, imagine that. So the battery that it comes with the mobile, they generally operate at 5 volt, 3.7 volt to 5 volt. Okay, so now if you want to make some kind of visual indication like our mobile chargers, then using bulb will be a big difficult, because the space it occupies is also more, and the voltage it needs to lit up is also more. So that's why we are using LED. But LED is a very sensitive component.
Sir,
Yeah.
if you use
uh,
resistor to burn a light
uh.
bulb, what will happen?
So if you use a resistor to have connect with bulb, the intensity of the light will be reduced. Okay, suppose if that bulb is
Okay, so
sufficient
it
to,
will not glow properly.
it will not glow properly. Exactly, you can understand something like this. So I will explain the purpose of resistor here. So the led is a very sensitive component. So if you allow more current to pass through the led, it will burn itself. It will lit up for a very short period with a great brightness, but instantly it will burn itself because of the intensity of current. So now, before explaining the resistor, I am asking you one question. Let's say you are running on a playground. Okay, then you are running inside a swimming pool. You are running, not swimming, you are running. Okay, so which one will be more difficult for you? Is it the running on the
What's
playground?
the
Running.
resistance?
Yeah, so running inside the swimming pool will be very difficult, right?
Yes, sir.
Correct. Yeah.
Yes, sir.
Why it is difficult? Why it is easy for you
Because
to
the
run?
water will not because the water will not uh, allow us to run properly.
Exactly.
Because the
So
water
yeah, go ahead, Arshad.
because the water is denser than us, sir.
Yes, exactly. All answers are correct. So what water is doing? It is opposing you. It is opposing your motion more than air. It is having more viscosity, more density, so it is opposing your motion. Okay, air, it is a less denser, less viscous, so you can easily flow through air, but you cannot, I mean, you can easily run through air, but you cannot do the same in water. So which means water is resisting you, it is providing the resistance. Okay, so it is providing some opposition power to your running. The same thing is happening in the resistor. Imagine yourself as the current. When current is trying to run through wire, it can run so fast, it can go through the component so fast. But if it needs to go through some resistor like water, like how you are going through the water, it is very difficult for you
Sir,
to,
it
yeah,
can pass through water so easily, sir.
current can pass through easily, but you cannot pass through water easily, right?
Yes, sir.
So it is like I'm giving you some analogy, like how it is difficult for you to run through water. Same way, current
Wire
finds.
cannot run through.
No, no, I'm saying how it is difficult for you to run through water is difficult. Similarly, current has difficulty to pass through resistor. Do you get my point now?
Yes, sir.
So it will find it difficult to pass through resistor. So that is why now LED is safe, because the current is finding a tough time to pass through the resistor, and so the LED is safe now.
Okay.
Do you all understand, Talha, Arshad?
Yes, sir.
Yeah. So when you have a higher voltage power source like 10-volt battery, or the battery that we are using in our cars, it will be 12 volt. In our inverter, that is also 12 volt. Now if you want to connect the 12-volt battery, and if you see in our inverters, there will be LEDs. Okay, so the light you are seeing, that will be LEDs. So if you want to connect the LEDs, you should have resistor. Without resistor, the LED will burn itself if the voltage is more than something like 2 volts, right? It's clear, right? Okay, I take this as clear. Okay, so we connected bulb, we connected LED, and you found the difference between what the connection between bulb and LED would differ. For example, if you take bulb, you can connect to either terminal of the bulb to the battery. But if it is LED, you should connect positive to positive, negative to negative. Then only it will properly glow. And for a bulb, you can connect it directly without any resistor. But if you want to connect it to the LED, you need to connect through resistor always. That is the safer side, right? Some message. Okay. Is it clear?
Yes,
Oh,
sir.
okay, great. Now let's move on to microcontroller. Now let's say, okay, before moving on to microcontroller, I will explain something. Now, if I click start simulation, the LED is glowing. If I click stop simulation, the LED is not glowing. Fine. That is what I expect to happen. But in our real world experience, let's say you are having fan. So how are you controlling the switching on and switching off of the fan? Are you going to
With
click
electric
some
switch, sir.
electric switch? Yeah,
Electric switch.
exactly. You are not going to click something like start simulation, stop simulation, right? So the start simulation should start the simulation, but during the simulation, there should be some method to turn off and turn on the LED. So we are going to connect some switch. So this is slide switch. There are 3 pins generally in our switches. If it is a single way switch, like there will be only one switch to turn on your fan. Sometimes have you seen there will be 2 switches, one will be near bed and one will be near some other place, so that you can on at one place and you can off at other place. You know, you are familiar with that, right?
Yes, sir.
Okay, so that is two-way switch. Generally in one-way switch there will be uh, only 2 terminals. Before asking about this, I already explained you this in the bulb. If I take this connection away, uh, okay, doesn't allow me. Okay, so now if I click start simulation, nothing will happen. That you all already know, right? The LED will not glow because it is not connected. Now this is, let's say there is a wire coming out of here till this point. Okay, assume that. Now if I click start simulation, will it glow?
No,
Sorry,
it will not glow, sir.
it will not glow. Why? Because the wire is not yet connected to the LED, right?
Yes, sir.
Okay, so even if you have something,
So what is mean by this?
sorry, this is some programmable switches that we can see later. Okay, if you want, I can show you at the end of this class what we can do with this. Just I will show you. I cannot explain you at this point of time. Okay, someone mistakenly put some line, so I'm trying to delete that. Okay, so you all agree that even if you take wire and keep it somewhat near, the LED will not glow unless otherwise you connect it to it, right?
Yes.
So the switch also functions in the very same way.
Sir, I will show you
You will show what?
how it's glowing. Can I show you, sir? With my pen.
Yeah, I will draw it and explain. You cannot show, right? It is Talha, isn't it? Or Arshad?
Tell her.
Okay, I will show what is happening here. So there will be a metal connection inside. Okay, what would be the next connection, Talha? Yes. Okay, I will finish it for you. Okay, are you happy? Okay, you stop the annotation. I will explain it. So generally, switches will be something like this. Okay.
Is it correct, sir?
Yes, correct. So the switches will be somewhat similar to this. Now let's say I have connected like it, and then connecting something like this. So this is still a open circuit because the metal piece is open and just air is between these two metal pieces. Unless otherwise it closes, the LED will not glow. That you understood, right, Arshad?
Yes, sir.
Okay. Now, if you want to make it to connect, you need to press this metal piece to make it to touch with this one. Then it will glow. Correct? Okay.
Yes, sir.
Okay. Now, this point, you can assume something like this here. Okay. And this point, you can assume this one. Okay.
Okay, sir.
Now, there is a third connector. So, what does that mean? Third point is there. What does that mean? It means so this is the, can I change color? Okay.
For the push button, four sides are there.
Yeah, yeah. So this point, you can assume this one. Okay. So wherever I put line, you need to connect it to, you need in your imagination, you need to connect it to these points. Do you all understand this?
Yes, sir.
So
Yes.
when this will be called as common. Okay. So when this common is not connected to one pin, it will be connected to another pin.
Okay, sir.
Okay. So let's say um, let's say you are having one connection. So this is common because it can swing between these 2 points. It can either connect to this one, this one. So that's why we are calling it as common.
Okay.
You understood, right?
Yes, sir.
Okay. Now we are going to make bulb and LED in our circuit. Okay. First, let's make LED with switch. So I'm going to connect it like this. Like this, like this, like this, and finally here. If you keep the cursor on it, it will tell you this is the common. And this is terminal 1 and this is terminal 2. Now if I click start simulation, it is glowing. Why? This one and this one are already connected. You see here. Now if I click it, if I now these two are connected. Since nothing is connected here, the open circuit will be there from here to here. And this LED is also in the open air. Is it clear?
Sir, try to connect that also, sir. The third one.
Yeah, yeah, I will connect. I will connect. So is it clear till this point, Arshad and Talha?
Yes, sir.
Okay. Now let's connect a bulb.
I'll have to.
So the common is coming from battery. So when this position of the button is in this direction, it can give current to this pin. And when this position is in the other place, it can give current to this position, right? Now we are going to connect this one. So this will be the positive of the battery coming to bulb, and this will be the negative terminal. if I click start simulation, which one will glow, battery or bulb?
Bulb and LED.
Bulb and LED, yeah?
Now the bulb will glow, sir.
Okay, so what is the other answer?
If we press the switch, the LED will glow.
If I press the switch, if I move, when I click start simulation, if the switch is in the same position, which one will glow? That's my question.
Bulb.
Yeah.
Bulb, sir.
Let's check that. Yes. So if I click this button,
Correct.
now LED will glow.
Correct.
Okay. 100 marks to both of you. So you understood how this switch is functioning, right?
Yes, sir.
Okay. Now I'm clicking stop simulation and I'm removing bulb. I just added bulb to explain you. While you are in the simulation, you cannot delete these components. You need to stop simulation, then
Yes,
only
sir.
you can delete it. Okay, fine. Now I'm clicking start simulation. I can turn it off and I can turn it on. Turn it off, turn it on. Just like how we do it in our household switches. You don't have to click stop simulation.
Sir, can you add another switch?
Another switcher.
Yes,
Why?
sir.
To control.
I don't like this.
You don't like this, huh?
Yes, sir.
So I don't have any other switch. You need to ask Tinkercad to add more
It's okay,
switches.
it's
Okay. Let's see if there is some other switch. There is only push button. This
There, no,
push,
sir, the red color. The red color one.
this one is
Ah.
little different. You will not understand it.
It's okay, sir. It's okay, sir.
Okay.
It's okay, sir. Sorry, sorry.
No problem, no problem. This is different type of switch that you will see in some antenna type.
Okay.
So this will be a little difficult. This is push button. So as long as you press the button, the LED will glow. If you release it, it will not glow. Okay, so this is a different one. This is the only switch. So that's why it is called as button. This one is called as a switch. This is the only switch available here. So that's why I am forced to use it. Otherwise, I would use a different switch. Okay.
It's okay. It's okay, sir.
Okay, fine. So you understood this concept, right? Like switches, LED, resistor, and battery. Correct? Okay. Now, during the simulation, if I want, I'm stopping it. If I don't want, I mean, if I don't want, I am turning it off. If I want, I'm turning it on. So I'm doing it through some human touch. I'm making some changes in the switch to make the LED to glow or to make the LED to not glow. Right? Okay. Now we are going to introduce something called microcontroller. So this microcontroller, it is going to do this job for us without our human touch. How? What is how? Which how?
How it will glow automatically?
Yeah, that's what we are going to see. Fine. So there is a microcontroller. The microcontroller will do this job like turning on the LED, turning off the LED without our human intervention. If you click start simulation, it should automatically lit up the LED and it should turn it off. And then it should turn it on and then it should turn it off. That's what we are going to do. That's what the traffic light signal is doing, right? I explained, I showed you the so this is done in Tinkercad. I just took the video. I'll show you. So it is turning on one LED and I'm not touching anything. It is turning off the particular LED. Now you see I'm clicking start simulation. So the green is glowing. After 5 seconds, it will move to yellow. I'm not touching anything. Okay. My cursor is still there on the stop simulation. It went to yellow and then it went to red. And again, it is coming to green.
Sir, now Yahya called me. Now he's gonna join.
Okay, no problem. Let him join.
Sir, you used coding, sir.
Yes, exactly. We are going to see the coding and all. Okay, did you all understand this, what we are
Yes, sir.
trying to do? So I'm not touching anything, it is automatically moving from one LED to another LED to another LED. That's what we are
Okay.
going to do now. Okay, am I going too fast? Do you want to be a little bit slow?
No, sir. No, sir. No, sir. No,
No,
sir. Thank
right? Okay, jazakallah khaira. Okay, let's, we are going to see coding in this. Okay, now we are going to add something called Arduino. This is the microcontroller I was talking about.
you.
Hmm.
Sir, what is mean by Arduino kit, sir?
Arduino kit, Arduino,
Here, John.
yeah, yeah, I saw that. Arduino means it is a type of microcontroller. There are a lot of microcontrollers. Okay, the actual microcontroller is, you see the black color thing here. That is what actual microcontroller. So the other setups are there to make things easy for us. For example, um, have you seen the AC, not a split AC, the window AC like used in 2000, early
Yes, sir.
2000s?
Yes, sir. Yes, sir.
So
Yes, sir.
there is no remote for that. You need to go and turn that knob.
Yes, sir.
So now we are having remote and we are having Wi-Fi control and all those things, because
Yes, sir.
still you are getting the chill air from the old ACs and new ACs. The purpose is
Yes,
solved,
sir.
but it is to facilitate you. It is to make things very easy for you. We are having remote and all those things. Similarly, when
Yeah.
I was studying before, like I completed my college in 2013. Okay, so assume that it is in 2005 or 2007. People used to code only with this microcontroller, with this black color part. That is actually the real microcontroller, and it is very difficult to code. Okay, now with this Arduino, it is easy to code for you. Okay, so this Arduino, we are going to buy this Arduino component. This is 400 rupees, I told you, right? So this will be around 400 rupees. We are going to buy the component, we are going to connect the LEDs, and we are going to make the real traffic light signal that I showed you in the videos. That will be our final step. Okay, do you like it, or do you want to do something else?
I like it.
Okay, so at this initial stage, it is good to do such kind of a small project, then we can extend it to a bigger
Okay,
project.
sir.
Okay, inshallah. Okay, so this is Arduino. So once you add the Arduino component and click start simulation, you can see this cable is getting inserted, and there will be an LED glowing here, which means it is turned on. Okay, when you click stop simulation, this is how it will be. So when you
And
click,
if you click start simulation near the letter L, it's
yes, that
glowing red
glowing,
color
glowing,
light.
glowing, glowing. Yeah, yeah, yeah. I will come to that point. Okay. So you are noticing, right? This is inserting. Yeah, I know, Talha. So this cord is getting inserted, and this LED is turning on. Correct. So I will do it once again.
Yes, sir.
So it is inserted, and this green LED is
Yes,
turning
sir.
on. Just ignore
Yes,
this
sir.
light as of now. This LED as of now. Okay.
Huh.
So this is fine. Now, if you click it, so there are a lot of pins here, correct? So we are going to concentrate only from here to here, and this. We are going to concentrate only these pins as an initial stage. Okay, you don't have to know everything in this microcontroller to do starting stuffs. So this is what we are going to concentrate, these two places. Okay. Now, now
Yes, sir.
no, nothing. I will come to the point. Okay. Now we are going to code this microcontroller to do something like I told you. Like it will turn on the LED and turn off the LED without our human intervention. That's what it is already doing, right? So if I start simulation, it is getting lit up for a second and then it is going off for a second and then it is coming back. You all understood, right? I'm not touching anything. It is doing automatically. It's clear? Talha, Arshad, Yahya? Yeah, sorry.
What's the symbol in the cable up, sir? The
Yes.
like
This
energy.
one, this one.
I'll show you. Yes,
Yeah,
this
this one,
one.
right? The energy. Yeah. It means it is powered up. This cable, you will insert one end of the cable in laptop and then the other cable will be, the other part of the cable will be inserted into the microcontroller. So it is saying that it is
Okay.
powered in. That's all.
Okay. Okay.
Okay. So this LED is glowing without human intervention, right? It is turning on, turning off. There is no switch. It is automatically doing. Before that, we are going to do some stuff like now this microcontroller is also getting some power, correct? Which means we can power an LED using this microcontroller, just like how we powered using the battery. So this will also be a source of power now. Okay, I'm going to add a LED. What should be the next component we should add? Hmm?
Resistor.
Exactly.
Sir,
We,
when you are typing LED, there was another LED, sir. What
yes,
is
yes.
that for?
So there are different types of LED. You see, this is called RGB LED. So using this, you can generate different colors like red, blue, and green colors. So this one will be called as green. This is blue, and this is this is red. Okay, you can generate a different color patterns. So
Please show me the RGB LED.
RGB LED I should show. I will show it later. Okay, let's complete this one. We have plenty of time. Inshallah, I will show you. Okay. So I connected resistor. If you see here, this is 5 volt. This entire Arduino works in 5 volt. Earlier, what was the voltage we dealt with? The battery. Do you remember?
What, sir?
Earlier, we used a battery, right? What is the voltage? Do you all
Yes,
remember?
sir. 9 volt.
Exactly. So what we are going to give connection here, it is 5 volt. Okay. So 5 volt means it is the positive. So I am turning it to red. And so what will be the negative? That's the next question. Negative in microcontroller means you whatever.
10.
Huh? What is that?
4, sir.
No. Wherever you are seeing G and D, that means ground. That will be the negative. Okay. The very next you see, this is the negative. Okay. Now if I click start simulation, this LED will glow. It's glowing, right? You all can see, right?
Yes, sir.
Okay. So just
How will
ignore.
it off?
How? Sorry.
How will it off and on?
Off and on, I will come to the point later. So now you all agree that this microcontroller is getting some power and it is giving out some power for some other applications also. That's
Yes,
what
sir.
I want to prove here. So the LED is glowing. it is also serving as a power source. Like how we are having battery, you can power an LED using this Arduino microcontroller. It's clear, right? Arshad, Talha, it's clear, right?
Yes, sir.
Okay. Can I move to the next point?
Yes, sir.
Okay. The next point is break. Okay. So we will
Okay,
come
sir.
back, inshallah, and we will discuss more about this.
Okay, sir.
I will stop the simulation. If you want, you can practice this Arduino in your computer. I don't know if
Okay.
Yahya is having computer. Arshad, you can practice this Arduino stuff and all those things. Inshallah, I will explain this little later. For a time being, I will tell you only one thing. This 13th pin is there, right? It is written like 0 to 13 here. This is what we are going to concentrate. So the 13th pin is connected to this LED.
Okay,
Okay.
sir. Okay.
Suppose if you want to, you just think about it after we resume our class. We will see. We will. We will see how you can make this LED to glow. I will tell you
Okay,
that
sir.
the 13th pin is connected to this LED, and we need to
Okay.
change this connection to make this LED to blink like this one. You just think
Okay,
about the
sir.
connection.